Previously, I posted this question. In this video, we want to provide an answer to this question. We are to determine which of the bulbs glow brighter. We are given a 60 watt 240 volts bulb and a 100 watts 240 volts bulbs, both connected in series across a 240 volt supply. Our target is to determine which of the bulb will glow brighter in this scenario. These are the ratings of the bulb. And following the ratings of the bulb, we can determine the resistance of each of these bulbs. And that is the first thing to do. If you're given the power and the voltage of a device, to obtain its resistance is quite easy. We just record the formula that power equals V squared all over R. If we make R subject of formula, the resistance becomes V squared all over P. So with this formula, we can obtain the resistance of the 60 watt bulbs and the resistance of the 100 watt bulb. Starting with the 60 watt bulb, the resistance of the 60 watt bulb will equal to 240 squared. That is the voltage squared, the rated voltage, not the voltage applied across the circuit. We are looking at the ratings of the bulb and the resistance of the bulb independent of the connection it is made to. 240 all over 60, 240 squared all over 60, that gives us 960 ohms. That means the resistance of this bulb is 960. For a 100 watt bulb at a 240 volts rated power supply, the resistance of the 100 watts will be 240 squared divided by 100, the power, and that is 576 ohms. So with this, we now know the resistance of each of these bulbs as rated. Remember, these resistances are assumed to be constant, but they depend on temperature. So let's quickly make a statement that these resistances are assumed to be constant, but depends on temperature. What it means is that temperature affects this value. However, the resistance of the 60 watt bulb will always be higher than the resistance of the 100 watt bulb, given that they are rated at 240 volts supply. So take note of that. And we are going to continue on the ground that these resistors are constant as applied to these bulbs. So in series, we now have a 960 ohms resistor for the 60 watt bulb in series with a 576 ohm resistor for the 100 watts bulb. These bulbs are in series. Because they are in series, it means the same amount of current flows through them. Let's identify the current as I. So if a current I flows because of a 240 volts applied across these two bulbs, the current I will flow through this bulb and this bulb at the same time. So they are said to be connected in series. In series, the amount of power dissipated by each of these bulbs will be different because they have different resistances. Depending on the value of the power dissipated, we can be able to tell which one is brighter than the other, because the one that dissipates the higher power will be brighter than the one that dissipated the lower power. So let's start by calculating the current I flowing through this series connection. In the current, according to Ohm's law, is V over R. So if we take the voltage to be 240, which is the applied voltage, of course, the total resistance is the sum of this and this in series. So we have I equals 240 all over 960 plus 576. That gives us the current flowing through the circuit to be equal to 0.156 amps. Let's move on. Now we know the current I flowing through the circuit. The current flowing through both bulbs is 0.156 amp. That same current will cause the bulb to dissipate power due to their resistances. So the power that each of the bulb dissipates is what we are going to look at now. Since the current is constant, let's use the power formula P equals I squared R, where I is that common current flowing and R will be the resistance of each of these bulbs. Starting with the power dissipated by the 60 watt bulb, power for the 60 watt bulb dissipated will be equal to 0.156 squared, current is 0.156, times 960, the resistance of the 60 watt bulb. That will give us 23.4 watts. That means the 60 watt bulb connected across the 240 volt supply in series with this will dissipate 23.4 watts. Let's look at what a 100 watt bulb will dissipate in this condition. 0.156 squared, remember the current is the same across both bulbs in series, times 576 ohms, the resistance of the 100 watts bulb. That gives us 14 watts. In other words, a 100 watt bulbs connected in series with the 60 watt bulbs to a 240 volt supply will dissipate 14 watts. Now look at these two. Which one dissipates the higher amount of power? Of course, it's a 60 watt bulb. It therefore means that this bulb will glow brighter. From this analysis, we can conclude that the 60 watt 240 volt bulb glows brighter simply because it dissipates higher amount of power than the 100 watt bulbs when they are connected in series to a 240 volt supply. You can see it's very simple and straightforward, and I believe you understood it. If I'm correct, then you have a simple one to do. Here it is. Try this. Which bulb glows brighter in this situation? Please put your answer in the comment section. I have changed the ratings of the 60 watt bulb to a 120 volts bulb, while the 100 watts remains at 240 volts. But these two bulbs are now connected in series across a 120 volt supply. Determine which of these bulbs will glow brighter, and feel free to use the comment section. Thank you for watching this video and hope to see you in our next video.